We are talking about least squares regression today. Least squares regression is just another name for linear regression or finding the best fit line. So notice in parentheses there I define it. We're talking about the sum of the squared residuals. And they're trying to make that sum as small as possible. So there are some formulas to get A, the y-intercept. In stats, by the way, we, for some odd reason, like to change letters around, but it still kind of follows the formula of y equals mx plus b. So that number, that constant all by itself is still the y-intercept. The number attached to x is still the slope. But we call it least square regression, and we use A and B. And there are some formulas. We'll look at those down the road. We're going to let the calculator do all the math, but there in parentheses right here is what it's doing. And I haven't even talked about a residual. It's really hard to teach this because it's like it jumps from the beginning of the chapter to the end of the chapter, and it's hard to cover it all in one shot because that's referring to something we cover later in the chapter or later this week. So a residual is the difference between what really happened with the y and the predicted y. So it's a difference. It's like how far off the prediction is. And it's summing up the squares of those residuals. And it's getting the least one. We want the least possible. And we get an A and we get a B. So like I typed at the very bottom of the screen, A is the y-intercept and B is the slope. So we'll practice defining and interpreting those and go from there. So we have this problem right here. I actually don't know how to pronounce that word. I think it's Gessel, but it could be Giselle. Gessel? I don't know. I don't know how to say that. But they're taking ages of kids when they speak their first word, and they're looking at a Gessel adaptive score, and they're seeing if they're linearly related. A key word here is age. Where did they type it? In months. So we're talking about kids. When I first looked at the numbers, I was like, a 26-year-old's not a kid, but that's in months. All right. And we have 21 of these values. So if I scroll down a little, you can see the whole set. So let's see. Yeah, that's the very last value. Take a moment and practice making a scatter plot. So title it, do your axes, find your min, find your max, and we will go from there. Notice we need to calculate R, and we need to get the estimates for the y-intercept and the slope. So even though we can sketch this by hand, we do need to get the data in the calculator as well. So go in whatever order you want. I'm going to go ahead and start making a scatter plot. So if you want to pause it and compare your scatter plot to mine, you can do that. All right, so here goes my scatter plot process. I am looking at Gessel, whoops, 1S, scores, and age. All right, let's say and first word spoken. Let's just say that. Okay. And I need a y-axis and an x-axis. I see my min is at 7, I believe. And my max is at 42. I'm going to do a quick skim. I want to make sure I'm ready with 7. Don't see anything smaller. My min score, I think, is 57. And my max is 121. skim through that real quick. Okay, so I need to go 7 to 42 and 57 to 21. So maybe if we start at 5, and these are ages in months, and go by 5s up to 40 or 45, doesn't matter. I think that's enough. And then I have my scores going from 57 to 121, so maybe start at 50 and go by 10s up to 120. I think that'll work. You know what, I'm going to spread these out a little more, pretty close. Because one thing I discovered earlier is we have a lot of overlap in this graph. All right, now we're ready to start making dots. Doesn't have to be perfect. Just do your best. It's a funny looking dot. There we go. I feel like I already made that dot. Put it right next to it. I feel like I already got lost. 1184. I don't know. 11102. See, I feel like I already made that dot. A lot of overlap. And then we got this weird one. And another in there. My gosh. Okay, so there's our scatter plot. Hopefully that was easy. Let me turn off the ink, show you on the calculator. So on the calculator, we want to go Menu, Stats, Stat Calc. I like the 4th choice because it uses A and B. I named mine A and B and hit OK. And if you go down a little bit, you can see R. So there that is. And we want to go back to our graph. And it said to calculate R in the least square regression equation. So I think in this video we only have time to write down the results. We got R as negative 0.6403. I got A, which is my y-intercept. Let me label that right here. As 109.874. And B, which is my slope, as negative 1.1270. 0. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. 70. I'm going off of, where do I have room? I'm going off of, I'll write it right above the word this. Only instead of y and x, I want to use score and age. So score hat, we use that little arrow thing above the y and call it a hat. So y hat is 109.874 minus 1.1270 age. I just ran out of room. And then when I plot the line, pick 2 points. Plug in, and we have 2 observations. So score hat equals 109.874 minus 1.127010. I picked 10. So I plug that in, and I get a predicted score of 98.6. Let's make a dot for that. Let me change color so it stands out. And I plug in, let's say 17. It's up to you. Nothing magical about what X values you pick. And I get 90.7. Let's make a dot for that guy, and we will call it a day on this video. And connect the dots. All right, that's how to plot a line and use the least square regression equation right there. All right, see you in class. Bye.